What in the world is happening? How is that Ruby? Hello, friends. Welcome back. This will be part 2 of our bytecode series for Natalie, where we generated bytecode in the last video. I think in this video, we're going to be reading it back in, decoding those instructions, and we're not going to be executing them yet. That will probably be part 3. But I want to get right into it, but I do need to give you just a little bit of an update since the last video. Our friend Herwin, who is a smart cookie, added one commit with a whole lot more of a commit message than change. There's only 2 changes. Herwin changed the Q here to a W and the L here to a W. So what is W? It is a, let's see, BER. What does it stand for? I've already forgotten. Basic something. Don't remember. BER encoded, basic encoding rule. So it's a part of X690, and Herwin had implemented this back in January, and I'd completely forgotten about it. So what does it do? It lets you encode an integer in only the number of bytes that you need. So all of that talk last video about using up all that extra space, I didn't have to do that. So that's pretty cool. And I'll just show you real quickly what that looks like. We'll just do b hello.b examples hello.rb and hex dump that file. You can see it's already quite a bit shorter, and the this J is the let's see, I guess a 4A is the instruction number, and 0B is the length of the string. So 0B here is 11. That makes sense. But if it were longer, I guess we could show that, right? Could say hello world. We could just say x times 1,000, and we ran this again. Oh, yeah, I can't do it that way. Of course, I don't have that instruction yet. So let's just make it really big. I think as long as it's more than 128, I think it will overflow that. Let's try that, and nope, let's try that. Okay, so now we can see that these 2 bytes are the length. So hello starts here, and 82 and 0f equal however many bytes that was. And so we're going to have to decode that. So that does make it a little more complicated, but it does make our output a lot more compact. So I really like that. And just wanted to give you that backstory there. Let's check out examples. Also made another change where I added, let's see. What did I do? Oh yeah, I actually explicitly numbered all these. I realized I did not want the numbers changing, and I didn't want load order to affect it, and I didn't want to have to load up all the instruction classes to get the names out. So I went ahead and made this little hash, or big hash as it is, with the numbers encoded. And I think that we'll probably end up using this meta for something else. Maybe could even say how many things that this instruction pops off the stack versus how many arguments it takes versus some other information, or maybe whether or not it pushes something onto the stack. I think, yeah, some of our instructions don't. Some of them don't push things onto the stack. So yeah, it'd be kind of cool to have that information in the future. So I just made a meta thing for that. Okay, whew, all that out of the way. What I really want to do here is create a new VM class. And so first of all, I made this first little script will let me decode a BER encoded integer 1 byte at a time. And so that way I can read from the IO stream, I can get a byte, decode it, and this is the algorithm. Just real quickly, Ruby BER, just wanted to prove that I can get out the integer and then any bytes after it. So if this number is 127, that's 1 byte long. Actually, it'd be kind of cool if I said puts get another byte, and then I said puts get first byte, just to kind of visualize that. So we got 1 byte for the 127, and then we got the rest. But if I change this to 128, well, that flows over to 2 bytes. So we do get first byte, get another byte. So we had to get 2 bytes to get this 128. And if I make this a really large number, then you should see that run a few times, and we had to get 3 bytes to get that number out. So that was just me playing around, and I think I'm going to need this in my VM. So let's go back over here, source VM, edit source VM.rb, and we're just going to make a little class, def initialize, and it's going to take an IO object. And I'd like to be able to run it, so we'll say if file is the same as the main program, then we're going to do vm.new file.open argf.first. I want to read binary, I think, yes. And then we'll do execute, even though we're not going to execute anything, that's okay. We're going to pretend. I want to say byte is, I want to paste that thing I copied earlier, which was here. There we go. Put that there, and I don't need this debugging stuff. And result is 0. I think that's what I want. So you pass in the IO. I don't even need to pass in the IO because it's an instance variable. Yeah, so we'll just say, we'll call this read ber integer, and will it work like that? I think it might. So if we get a instruction number from the IO, get byte. Every instruction number is 1 byte, and then we have a case statement, num, and when something, right? Might as well put an else in there to say, oh my, that was not helpful. Else puts raise unhandled instruction number num. Okay. So what? How do we want to read those instruction numbers in? So we have this meta file over here, and we have this. So we kind of need to require that relative. It's in lib, Natalie, compiler, instructions, meta. It's really it's really buried in there. Relative. So I need a way to turn a number back into the symbol on the left side. So let's do instruction num2 name num. And I want to cache an inverted data structure of the right side. I want to cache that. So we'll say instruction names is this. Oops. Each with object. I want to loop over each key. So the left side will be the name. Then it will be the meta for that instruction. And then we'll have the hash that we are generating as a part of this, each with object. So, you know, this is kind of long. Let's move this over here. Instructions. Yeah, let's do that. It's a little bit easier to read. Hash hash meta num is equal to the name. And that will give me a hash that looks like 1 and alias global or whatever. Yeah, that should work. Okay, so now we want to return from this method instruction names. My tab key's not working. Instruction names dot fetch, because I want it to raise an error if it can't be found. And that should give me the name. So here I need instruction num to name. My autocomplete is going crazy today. So when it is push self, then we want to say, I'll just puts it out for now, push self. Ooh, what is the next instruction? I think we're done with this. Close that, close that, close that. Okay, do we have the hello.b? We do. Let's do source, and I don't think I'm going to need the BER thing anymore. BER. And hex dump c hello. So I've got this file, and I'm going to, what am I going to do with it? I'm going to run Natalie with the vm.rb. I want to pass in hello.b. Does that work? Uninitialized constant argv because it's argv, and typed that wrong. Okay, so we got push self, and then it just quit. Did I forget? Oh yeah, I don't have a loop. Okay, we'll do it in a loop. And so I want to see an error here. Unhandle instruction number 74. Well, that's not very helpful. So let's do name equals name and handle instruction. Push string when push string. So I want to do that, and then this is where we need to go look at how we did push string. So it's the byte size followed by the string itself. So we'll say size is read BER integer. Yeah, and then we want to do what? io.read size, unpack. I don't even know if I need to unpack it, honestly, because won't it just be bytes? So this is push string. Yeah, I'm gonna try this. Let's see if it works. String.spect size is size. So does it work? It does. I'd like to regenerate that hello.b from here. Let's try that again so it's not so long. But that does prove that it can read more than 1 byte for the size. That's pretty cool. Push string hello world size is 11. Yeah, I don't need to run unpack on raw bytes, I don't think. I probably do, just out of curiosity, encoding. What encoding is that reading that in as? Encoding ASCII 8-bit. I think that's good. We may at some point need to put the encoding in that instruction output. In fact, I'm almost certain we will, but we'll do that later. That's not a problem. We'll come back to it. What's the next instruction? Push arg count. Push arg count is pretty easy, I think. Count. Count is, did we push arg count? I guess we could do a W here too, and then this could be read BER integer. I do need to re-encode that, and then run this. And we got push arg count 1, cool, and then send. When send instruction. Okay, we got lots of fun stuff here. For this one, it's going to be a size, so we'll just copy this. And then it's going to be a string from that size. This is too easy. This is way too easy. And then we need 4 booleans. So let's do io.read4 to unpack C4. I don't know why I like just typing it out, but that's probably dumb. So receiver is self, followed by with block, followed by args array on stack, followed by has keyword hash. Bools. So puts send. How did we write it here? Could I do something like this? And this was message. And this is that, and that's that, and that's that, and that's that. Cool. Does it work? No, because I typed put. How about puts? Unhandled instruction pop. Did it do it? Send puts to self with block. Args array on stack has keyword hash. Oh, that's so cool. I don't think. Wait, that doesn't seem right, does it? Because it doesn't have a block. The args array is not on the stack, and it does not have a keyword hash. So I did something wrong. I think I got something backwards. Oh, because I'm returning integers. Okay, so if I print bools here, yeah, it's 1 and then 3 zeros. So what I really want to map over those and then say, let's call these ints, I'll say flags, and we'll say if the flag is equal to 1, then it's true. Does that fix it? Yes, that looks a little bit better because the only one that was true was self. Okay, and I think the last one is pop. I'm trying to put these in alphabetical order. Pop. And that one's pretty easy because it's just a puts pop. Fetch key not found nil. Probably because we're at the end of the file. So when we get to nil, end of file, then we can just return. No. Oh, right, because num. How about we do this? We'll say return if num.nil. And we don't need this branch. That's so cool. Is this very similar? I did a little bit different output, but what in the world is happening? How is that Ruby? How is it? Wait, I have to see. I gave it the wrong file and it parsed it. What? Okay, Prism, I didn't expect that at all. How in the world did you do that? Okay. That's truly bizarre. So what I was trying to do is hello.rb. And if we run our VM with hello.b, we should get something very similar, even though I printed it out a little bit different. But it's push self, push string, hello world, size 11, arcount1, puts to self, and pop. We did it. We decoded them. Oh, that's so cool. Okay, I had to go for a walk there to figure out what I want to do next. I think I just want a very simple instruction class here. I don't necessarily want to rehydrate all of the actual instruction classes that we have. I might get there in the future, but for now, I just want to stick this data in a very simple instruction class. And so I guess it will have initialize and a type And then, man, I'm just going to do args for now. Type is type, and args is args. And attr reader type and args. So we could just say instruction.new type pop. How about execute does something else? Instructions is load instructions. And this is load instructions, and we'll make this private. And we'll get rid of that private. Move this up here. Load instructions, loop instructions is an array, and we'll do instructions like that. And so for now, let's print those instructions. I'll do it here. Okay, so something like that. And then we want to say instructions, instruction.new type is push arg count. Oh, I could just use the name type. Yeah, we'll say this is name. This is name, and the args is count. And instructions, let's just copy this one. It's going to be the same. And cool. So what does that look like? Nil, because we didn't return it. Instructions, so we don't want to return here. Let's do break. There are our instructions. It'd be cool if we could inspect those a little bit. So we'll do def inspect. Instruction type is type, and args is args.inspect. Yeah, I think that's pretty good, and we can just do puts on this so it's line by line. Oh, alias 2s2 inspect. Does that give us what we want? Yes. Okay, I really like this. I think this is a good start. I think we're going to be done here. I'm going to do some thinking about how I want to execute these instructions. So the, to do something, not sure what we're going to do here. But that'll be the next step. And hopefully by the time we get to the next video, I'll figure out what that's going to be. I'm going to RubyConf this next week, and we wanted to have something to hack on while I was there with people. And so here we go. Here's step 2 of executing our bytecode. Hopefully step 3 will be easy. I don't know. I don't know if that'll be a hard thing to do or not. So I want to compile this source VM to C++, and then I want to execute these instructions in our own runtime. So that's why I'm having a little bit of trouble figuring out what exactly my next step is going to be. So anyway, I hope you had fun. Hope you learned something, and I will talk to you in the next one. Bye.